Welcome to the lab demonstration on minimizing routing entries in OSPF version 2 networks using route summarization and area types on Ruckus ICX switches. In this video, I'll demonstrate how to summarize external routes at an ASBR and intra-AS routes at an ABR. I'll display how these changes impact a router's link state database and routing table. I'll reconfigure a normal OSPF area into a stub area and show how this impacts the link state database and the routing table as well. And finally, I'll convert a stub area into a total stubby area to further impact the link state database and routing table. This is the topology I'll be using for this lab demonstration. All of the routers have been pre-configured with the IP addresses shown here, except for the case of those configured on the multi-netted loopback 7 interface on the R3 San Jose router and the stub area for area 2. All areas are configured as normal areas at the beginning of the demonstration. Later, I'll be converting area 2 into a stub and showing the results in the routing table. Before we begin, let's get a current look at the OSPF topology. We'll run the show IP OSPF database summary command on the R4 San Diego router, which is an ABR between area 2 and area 0. Here we can see that area 0 has 3 router LSAs. These are the Seattle, San Jose, and San Diego routers. There are 2 network LSAs. One is the 192.168.20.0 network that exists between all 3 Seattle, San Jose, and San Diego routers through a layer 2 switch, and the 192.168.30 network that is the link between Seattle and San Jose. There's one summary ASBR LSA that comes in from area 3 that we'll look at a bit later. In area 2, we have 2 router LSAs. These are the Salt Lake City and San Diego routers. One network LSA, that's the 192.168.10 network between Salt Lake City and San Diego. 7 summary LSAs and 1 ASBR LSA. That's the same ASBR that's advertised from area 3, and we'll talk a little more about that later. And both have 9 AS external LSAs. Next, we'll move to the R5 Seattle router and look at the same command. So from the show IP OSPF database summary command, area 0 is going to be the same exactly as what we saw from the previous router, because area 0, all of the routers in it have the same link state database and have the same information. So we're looking at Seattle for area 3's information. In area 3, we have 2 router LSAs. That is the Seattle and Portland routers. We have 1 network LSA, that's the 192.168.50.0 network that exists between Portland and Seattle. We have 11 summary LSAs and no ASBR LSAs. Because the ASBR is inside this area, there are no type 4 ASBR LSAs. And it has the same 9 AS external LSAs as the other routers had. So let's jump into our Portland router and take a look at the IP routing table. Show IP route. And looking at this routing table, we have 22 routes, and a considerable portion of these are the 192.168.60 networks that are being learned through RIP at this router and being redistributed into OSPF. So we're taking all of these routes and redistributing into OSPF as individual routes. Now looking at these, you can see that these routes start at the 192.168.60.64 network, and the last usable address on the last 192.168.60 network is that 127. So we could, and these are all contiguous, so we could summarize all of these addresses in one update by finding the contiguous bits or summarized network bits that match every route in here, and sending that into the OSPF area. So if you look at these, they start at 192.168.60.64 and all the way up to 127. So we can summarize these with a network and mask of 192.168.60.64 with a 26-bit or 255.255.255.192 network mask. Now, the important thing about OSPF is in OSPF you can only summarize at boundaries. So you can summarize at ABRs or at ASBRs, but you can't summarize anywhere else. So if you've got a router that's just in one area, it cannot be a summarization point for any routes. So Portland, the one that we're in, luckily is an ASBR. It's taking all of these learned RIP routes and it's redistributing them into OSPF so that we can get to the RIP router, all of the Vancouver networks. So we want to fix that. So we're going to summarize all of these routes by configuring a setting under the router OSPF configuration context and summarizing what we send out as a single route out into the OSPF domain. Okay, so let's do that real quick. We'll get into configuration mode and we'll get into the router OSPF configuration context. Okay, so from here we run the summary-address command. Now in this command, we just follow up this command, we'll use the question mark here, with a IP address and then a mask of what it is we're going to summarize. So we're going to summarize the 192.168.60.64 network with a 26-bit mask. Okay, so we've made the configuration change. Now let's go ahead and get into, let's take a look at the routing table here first. Now, as I expected, but just want to show you that all of these routes are still present here. All of these 192.168.60 routes are still present in this router because this router learned all of them from RIP. So the point of this is not for every router to minimize their routing table. What it is for this ASBR to send into the OSPF domain a summarized route of how to reach all of these RIP networks. So let's see how that impacts the rest of the network. I'm going to jump into a router that is a strictly an area 0 isolated router. So I'm going to go over to the San Jose R3 San Jose router, and I'm going to take a look at how things have changed since we made this change for the link state database. Okay, we're looking at the external database, and now we only have 2 entries in this external link state database. Previously, every one of those 192.168.60 networks were advertised and pushed into this external link state database, and now all of those are summarized as this 192.168.60.64 external link state. So this is great. This is going to help us. Now, this is what it looks like in our link state database. Let's see what this does to our route table. Remember, we didn't look at San Jose before, but all of these routers had the same route table, and we had 24 routes in that IP routing table. So let's take a look now. Now we're down to 15. So we cut down several routes in that routing table. We took 8 routes and cut them down to 1 with this one summarized route that's being advertised here. So this is the mask that we supplied to it, 192.168.60.64 with a 26-bit mask, and summarize that into OSPF. So this really did help us out in minimizing how large our routing table is in our network. Now, while we're looking at this routing table, take a look at these routes, these 192.168.40 routes. These are routes that we're getting from the Salt Lake City router. Down in Salt Lake City, we have a loopback interface with these 4 networks that are connected to it. Again, they look to be all contiguous, and they might be a good candidate for us to perform some summarization again. If we're looking at these, the first address is the 192.168.40.128, and the last one is 176/28. So the last usable address is the 191 address. So these are contiguous, and again, a 26-bit mask will actually work to summarize all these routes. So we can go into a router here, we'll talk about which one we can do that in, and summarize the 192.168.40.128 network with a 26-bit mask and cut out 4 of these entries and reduce them down to 1. So in order for us to do that, again, we can only make changes or do summarization at borders. So borders are either external borders or inner area borders. So these are routes that are internal OSPF routes. They're not external, so we need to do this at an ABR. So the ABR between Area 2, where Salt Lake is a Area 2 only router, is San Diego. So we're going to jump into the San Diego router, and we're going to make some changes that are going to summarize these routes into Area 0 and then spread out to Area 3 as well to summarize these four networks as a single summarized route. So let's go ahead and do that. So in San Diego, again, we're going to do this from the OSPF router OSPF configuration context. And as I said, this command is different than the command for summarizing external routes. So these commands, what we're going to do is we're going to do the area range command, but the area range command says from one area, I'm going to supply a range to summarize a group of addresses in that area. So all of those addresses, those 192.168.40.128 and the next three ranges are in area 2. So for us to do this, we're going to run the area 2 range, and then we're going to provide the network and mask we want to summarize those addresses. So what the system will do was it will look for any networks that fit within that range and cancel out the sending of those into area 0 and send this summarized network. So this network that we're going to send is 192.168.40.128 with a 26-bit mask. Okay, so now let's take another look at San Jose's routing table. And now what we see is all of those 192.168.40 networks are all summarized as one single route. And again, we've greatly diminished the size of the routing table. So we've diminished it by 3 routes. All 4 of the previous 192.168.40 networks are now summarized as a single route. So through those steps, we've been able to effectively diminish the size of our IP routing table from 22 routes for all of these networks down to only 12. So this is a lot easier to read and easier to look at when you're troubleshooting problems and looking for things in the network. It's a lot easier if you can summarize things and limit the size of your routing table, and then it'll get specific as you get closer to the destinations. But as much as you can summarize, it's really great and very helpful for the overall routing table and the ease of tracking things down and troubleshooting, as long as you're sure you do your summarization properly. Now another thing we can do is we can convert one of these areas into a stub area, and we can show you a few things again that will limit the size of the routing table and limit the scope of what's out here. So let's just jump over to, let's say, the Salt Lake City router, and we're going to run the show IP OSPF database summary command again. This just gives us a quick look at what's in the network. This is an area 2 only router, and it's got the 2 AS external LSAs that it's seen. So this is the same throughout the entire network. There are only 2 external LSAs. So to show the impact of a stub, I think what I want to do is I think I may want to jump into let's say the San Jose router, and we'll add a few more routes and redistribute those so that we can bump up the number of external routes that we're seeing in Salt Lake City. Because what I want to do next is I want to convert area 2 that Salt Lake City is a part of into a stub area, and I want to show you the impact of what that change does. So let's get over to the San Jose router, and we're going to add a few networks here. I'm just going to cut and paste this information in here, and we will go ahead and get that done. Okay, so we've created loopback interface 7. We've created 4 IP addresses. That's 192.168.80.1, .33, .65, and .97, all with 27-bit masks. So these are just connected networks to the San Jose router. So in order to get these into OSPF as external, we need to redistribute them. So I'm in the router OSPF context already, and I am just going to run the redistribute connected command and force these routes into OSPF as AS external LSAs. Okay, so that's done. Now we should be able to go over to Salt Lake City again, and take a look at the same output. So we'll just use the up arrow and run the command again. And now we have 6 AS external LSAs. So those 4 routes we put in, along with the other 2 that are already in the network, are now being advertised into Salt Lake City as AS external LSAs. So good deal. We're ready to go now. So the things we need to do now, and this is something you want to really do before or while you're setting up this network. You'll see as I go through this that this is not something you want to do on a live network unless you really have to, because in order to make an existing area stub, you have to really dismantle the entire area first and then make it a stub area. So just to give you that heads up, if you're considering stub areas in your network, it is really a lot easier if you make them a stub on their inception, not after they've been operating as a normal area for a while. But this is an existing environment, and we're not going to really impact anything here except our lab. So let's go ahead and do this. We'll do this first. We'll start at the San Diego router. That's the ABR router between area 0 and area 2 for this area we want to make a stub. So let's go ahead and get started on this. The first thing we need to do is we need to remove the IP OSPF area 2 configuration from interface 113. So let's see. Okay, we've removed that from the interface. So now now we have to get into the router OSPF configuration context. And what we need to do here is we need to, we just did a area range command over here, and we have to remove that before we can remove the area. So let's go ahead and do that. No area 2 range, and we'll get rid of that. And then we do a no area 2. So now we've just removed area 2 completely. So now we've lost our neighbor adjacency with Salt Lake City because it's in area 2 and we're not even participating in OSPF anymore on that interface. So let's try to put all this back together. So first thing we need to do is redefine what this area is. So we still use the area 2 command, but now we want to define it as a stub. So now this is a stub area. And then we're going to do a 100 here. 100 sets the external metric for routes that come out of here. So we're just going to set that to 100. You have a little wiggle room on what value you want to use for that and how it impacts other routes in your network. So be a little bit careful with that. Then we want to put back in our area 2 range command. So I'm just going to copy it from up here and paste it in. So there's our range command again, so that we're summarizing the routes from area 2 back out into the network. And then we want to go into interface 113 again. And there we want to put this interface back into area 2. Okay, we're good here. So we're an area 2 interface again, and we're a stub, but unfortunately, we still can't establish a neighbor or peer relationship with the Salt Lake City router because the stub flag that's sent in hello messages doesn't match now. So we have the stub flag set while the Salt Lake City router does not. So we have to go and do some of the same stuff over here in Salt Lake City to get it to establish neighbor adjacency with us again. So from Salt Lake City, we're going to get into configuration mode. So we're in configuration mode and we have to do the same steps. So we need to go into interface 113 and we need to do the no IP OSPF area 0 or area 2, apologize for that, no IP OSPF area 2, and now we've removed that and then get into the router OSPF configuration context and run. We don't have the summarization stuff here, so we can just do the no area 2 command. Ooh, okay, there we go. We still have an interface, so we have an error because we have another interface in area 2. That interface, we actually have 2 of them. I forgot to get those out of here. We need to get into the 2 loopback interfaces and disable and remove the IP OSPF area 2 from those interfaces. So those interfaces are loopback 1 and loopback 7. and we'll know IP OSPF area 2, and we'll get into loopback 7, and do that again. Okay, so now we should have all of our interfaces out of area 0, and we can jump back into the router OSPF configuration context. Okay, so now it accepted it, so we're okay. We're back in business. So we can now redefine this area as a stub area. So this is area 2, stub, and 100. And we're good there. So now we can get back into all of these interfaces and rerun and re-enable area 2. Loop back 1, put it back in the area. And interface 7, or loopback 7, put it back in the area, and we should be back in business. So let's take a look at that. Let's see our show IP OSPF neighbor. We have full adjacency, which means now we agree that we're a stub area and everything matches for establishing neighbor adjacencies. So let's look at the show IP OSPF area command and see what we get. So what we see here is that we see now that this network area is now a stub area. So we can see that clearly from our router that this area now is a stub, the entire area 2. So again, all routers must agree of what type of area it is. Now let's see what this does to our external database. We have no external database entries. All right, well that's good. That's one thing we don't want to have. We have all those networks from San Jose, and we have those other networks that we don't need to know. We don't need to necessarily know everything about them because there's an ABR that reaches them. So we know how to get to our ABR, so we know how to get out. All right, so let's take a look at the IP routing table. So in our routing table, we still have most of the routes. We've dropped a few, and what we have in addition now is we have this default route. This default route is what this stub process does for us. So as I said, we don't have external entries for external networks in our routing table anymore, but they're still there. Right? Those networks still exist. Those are the 192.168.80 networks. Those still exist and they're out there, but they're external networks, and being a stub, we prevent those external LSAs from coming into the area. We solve that problem because we still want those networks reachable by the ABR, and that's the San Diego router, sending a default route into the OSPF area 2 to all of the other routers in that area and says, I'm the one who can get you there, even though you don't know those networks. So that's the workaround for eliminating routes from the routing table, because your only exit point should be your ABR, and we'll take that path. So we look good so far, but there's still a lot of other networks in here that perhaps we don't have to know about. Let's take a look at the link state database. So we'll look at the show IP OSPF database link state. And here we see our 2 router LSAs, network LSAs, and a whole bunch of summary LSAs. Now all these summary LSAs, these are routes that are generated from area 0 and area 3. So again, we have one path to these, and that's our ABR. So the idea is, do we really need all of these summary LSAs in our OSPF database if we're a stub area? The stub defines us as a dead end, and there's only one way out, and that's through the ABR. So we really don't need to see these. So we can do this with one change to one command on our San Diego router, and that will ensure that we don't have to see all these things down in Salt Lake. This action we're going to take is actually going to turn this stub area into a totally stubby area. Now there is no total stubby flag or anything like that. It's configured at the ABR and instructs the ABR to not send any of these summary LSAs and just send in that one for the default route. So let's go ahead and do that real quick. We'll head over to San Diego, right? And we'll get into the router OSPF configuration context. And from here, we're going to basically just append something to our area configuration command already. So we've already implemented this command. This is the area2 stub 100 command, right? We've already done this, but now we're going to add one more parameter to this. We're going to add the no summary parameter. So what this tells our ABR is to the other routers within this stub area, you are not going to forward summary LSAs. Okay, so easy. We didn't have to undo all of the OSPF configuration to add that no summary portion to it. So that is one piece you can add after the fact without having to completely undo your configuration. So let's see what this does in Salt Lake City. We're going to run the show IP OSPF database link state command again. And look at what we've done here. We've cut down the size of our OSPF link state database from 11 entries to 4. So just from a manageability standpoint of the router, this is a lot easier to manage and a lot easier to potentially troubleshoot and a lot of things. So let's see what this does to our IP routing table. So this really impacts our IP routing table as well, because now we only have 7 routes. Previously, let's see. We had 14 routes in our routing table. Most of those came from summaries, so we don't have to know about these anymore because, again, we need to know everything in our area, but outside of our area, the only path is through our ABR, so why not use a default route? So that's our demonstration on minimizing routing entries in OSPF networks using summarizations and different area types. So what we did is we talked about how you can summarize routes at ASBRs or ABRs, and those are the only places in OSPF you can perform summarization. We did that by doing some summarization commands, different commands that are available at the ASBR than there are at the ABR. We summarized a bunch of networks into single routes. Those affected the external link state database if they were sent in from the ASBR, and impacted the link state database, the local link state database, if they were done by an ABR. And then we converted a normal area into a stub area and watched how we cut out all of the external LSAs that were being injected into that stub area from the adjoining areas, and eliminated all of those from their link state database and their routing table, and the ASBR substituted those by sending a default route. And then we took that one step further by converting that area into a totally stubby area, which meant we're going to tell the ABR not only to suppress all of the external AS external routes, it's also going to suppress all of these summary routes, those type 3 LSAs, from going into the stub area as well. So that even further impacted how the size of the routing table on our stub area routers that are not the ABR, to minimize that route table for them. They only received a default route that goes through the ABR for anything that's not inside their area already. So hopefully this was helpful for you in understanding how to summarize and ways to change area types to limit the size and scope of the routing table. And I'll see you again for another demonstration later. I look forward to it. Thank you.